Welcome to this panel discussion on hardening supply networks for the future. I'm Dr. Ann Cheever, a program manager in the Biological Technologies Office at DARPA. I'm very pleased to be your moderator for this discussion today. Our hope is that this discussion will illustrate some of the challenges currently facing supply chains, and importantly, that it stimulates you as our audience to think of creative ways to improve the resiliency of supply chains, not just for the DoD, but for the entire US. So we're delighted to have a terrific lineup of panelists to help us dive into this topic today. I'm very pleased to introduce them to you. First, we have Wallace Patterson. Wally is a program manager at the Air Force Research Lab Materials and Manufacturing Directorate. He has over 36 years of experience as a civilian in the Department of the Air Force R&D Acquisition System. Mr. Patterson will be describing the various elements of a supply chain. Sunil Chandran is the Chief Science Officer and Head of Research and Development at Amyris, a synthetic biotechnology and biomanufacturing company. From his experience, he will introduce approaches to versatile feedstocks and adapting manufacturing for stronger supply chains. Carl McCants is a special assistant to the DARPA director focusing on Microsystems Technology Office's Electronics Resurgence Initiative and the National Network for Microelectronics Research and Development. His previous experience includes the Supply Chain and Cyber Directorate of the National Counterintelligence and Security Center, and he will share an introduction on security in supply chains. All right. So before we get into the discussion with our panelists, I'd like to briefly introduce you to some of the factors that can affect supply chains using these simple icons, which will appear on some of our subsequent slides. So as you can see, there are many possible sources of disruption. And without focusing on any specific product right now, this image is just meant to convey the level of complexity and global distribution that a notional supply chain may involve. So highlighting how raw materials, manufacturing facilities, and transportation of intermediates, as well as finished products, might be executed. So to set the stage for our panel discussion, we'd like to highlight a few recent and hopefully very recognizable examples of supply chain issues. And these have confronted the US very recently. For example, the baby formula shortage that came to a head a couple of months ago. So this originated with contamination issues in the production facility. And although the US was assisted by several international partners to alleviate the immediate crisis, this shortage was an emotionally charged one and identified many other challenges. Our other example that everyone is probably very familiar with is the COVID pandemic, which affected the supply of so many items needed for diagnostics and test kits to protect healthcare workers and individuals from infection, and even during the first year, the availability of respirators and oxygen to keep seriously ill patients alive. So while we're fortunate that this kind of event like a pandemic doesn't happen often, the COVID experience has shed the light on many challenges that faced our countries and the world's response. So hopefully this brief overview has given you a sense of what supply chains are and the many potential sources of disruption. So let's turn now to our panelists for some opening thoughts. And we'll start with Wally Patterson. He'll describe some various elements of supply chain, as well as weaknesses, and then how biomanufacturing can actually harden DoD supply networks.
Thank you, Ann. On a daily basis, we track items of interest or monitor the health of systems that we use. When you order a product online, the company you purchase the product from sends you an email saying your order has been processed and the shipment has been arranged. If you want to track that package, you can sign up for tracking emails or text alerts on your smartphone. The tracking website gives you the current status of the package, a timeline for a delivery, and sometimes even the exact location of the delivery vehicle. When the Air Force flies a mission, the aircraft and the pilot are monitored using thousands of sensors and a myriad of displays, indicating the status and health of numerous systems and subsystems. When you drive a car, your dashboard has dials, readouts, audio alerts, and warning lights. Some are digital, some are analog, some are simply trouble lights. That dashboard allows you to monitor the status and the health of your car in real time. So, why are we interested in biomanufacturing? Biotechnology is an engineering discipline that utilizes or exploits living systems to produce a wide range of technologies and products. Future advances in biotechnology will provide new operational capabilities to the Department of Defense across multiple domains, spanning materials, systems, military medicine, warfighter performance, and chem biodefense. So 3 examples you'll see on the chart are sustainable, clean sources of multi-purpose polymers, high-quality, zero-allergen alternative protein powders that have been produced in bioethanol facilities, and production of materials only possible through biology, producing specific structures, narrow size distribution, and high chemical purities, such as the image in the middle, which are actually magnetosomes. So in the Department of Defense, our technology supply chains that provide capabilities that go into our weapons platforms need bespoke dashboards to provide program managers with actionable insights into supply chain gaps and risks. A simple check engine light won't do. So I'm specifically interested in the biomanufacturing supply chain. And it's much more complex than that image you see on the left-hand side. It's more than just taking feedstock, putting it in a vat for fermentation, mixing it up, and out pops just a specific molecule or material at scale. It's very complex. It's more like that image on the right, with many tiers of suppliers and a variety of relationships in an ever-changing supply and demand network. So my goal is to completely identify the necessary elements that are required for a technology supply chain in order to manage risk, to predict gaps and disruptions, and then to mitigate vulnerabilities before they become a problem.
Thank you, Wally. That was a great case study to dive into. Let's move on to Sunil Chandran from Amyris. Sunil, over to you for some opening thoughts.
Thanks a lot, Anne. So at Amyris, what we do is we've developed a fermentation-based manufacturing platform which allows us to access a pretty wide range of chemicals. So our scientists can genetically modify common microbes like baker's yeast so that instead of making, say, ethanol from sugar, they now make other chemicals of value to industry and the government. We can use sugar from a variety of sources and convert them into these various chemicals. But at the end of the day, it's not just about coming up with a sustainable way of making those chemicals. It's about providing a reliable, scalable, and cost-effective manufacturing process that meets the demands of today's economy. Next slide, please. So biology is a rich source of greater than 300,000 chemicals. The issue is most of them have not been accessible to date. Now, we all know that the pharmaceutical sector has actually relied on biology as a source of medicines. The issue is that that industry is not as sensitive to cost pressures as, say, the commodity chemical space. So if I need to provide a chemical to the Department of Defense, I need to be cognizant of the cost of producing that chemical. And so what we have been able to do is with the current, as tools and technology platforms have started maturing, it's allowed us to access more and more of these chemicals. And so at Amyris, what we have done is actually access this rich source of chemicals. These chemicals, in turn, can be chemically converted into other molecules and materials. And so our goal at Amyris is to provide our partners in industry and the government with some of these biological targets. Next slide, please. So in 2015, as part of the DARPA 1,000 Molecules Living Foundries program, Amyris embarked on a project to exponentially increase our access to these molecules. Now, this being a DARPA program, we could afford to take some risks. So the standard usually is you try to work on maybe 5, 6 molecules at a time. This being DARPA, we actually went after 538 molecules in the first year, all at once. And so this required a paradigm shift in how we apply technology. So this was an integration of computational biology, automation, statistics, analytics, and of course, biology. So in the first year, we tried to access 538 molecules. We actually produced more than 250 of them. Now, there's a difference between producing it and detecting it versus providing enough material to the Department of Defense lab so that they could actually test it in their applications. And so over 4 years, we went through multiple iterations with DARPA and DoD labs. And towards the end of the program, we were able to provide 20 novel chemicals to the NOC-WD lab at China Lake and AFRL in Dayton, Ohio. And scientists there have been using these chemicals now in applications of interest to them. And so that program has now successfully closed, but even today we are providing them with greater and greater amounts of samples for them to do larger and larger amounts of testing. Last slide, please. So in summary, biology can provide us access to an entirely new class of materials that can either replace or enhance DoD capabilities. And so biomanufacturing is not just a sustainable way of making it, it also offers a domestic supply chain which is reliable and offers on-demand manufacturing for some of these chemicals. Thank you.
Thank you, Sunil. That was a great discussion of some alternative manufacturing options. So next we'll hear from Carl McCants from DARPA on challenges facing a clearly DoD-relevant topic, semiconductors, and securing supply chains. Carl, over to you.
Thank you, Ann. So we'll be talking about semiconductors, and in one of my more famous voices, what have I told you? That what you really need to be concerned about is the supply, because it affects everything from your automobiles to your televisions. And so if you were like me as a child, you pulled things apart, you looked at them, you'd find things like this inside of a television. If anybody remembers the big CRT televisions, the first generation of personal computers, I took things apart. I kind of sort of had the knack for engineering. But basically, this is what you'd see. And if you go on to the next slide, basically what we're talking about in manufacturing semiconductors, and keep in mind with each of the parts that you see there, aside from the people, there's a supply chain associated with those. When it comes to the design that comes forth from the mind of people here like you, there's a supply chain involved with the electronic design automation, the tools, the software tools that are used to, here's a way to represent that design in a method that the tools that are used to manufacture can understand. Within the manufacturing part itself, where you take that design and implement it onto a silicon wafer, there's the infrastructure and supply chain of the tools themselves, the hardware tools, there's the software tools, there's also the intellectual property involved with how those devices are manufactured. And I'll also point back to the design. There's intellectual property associated with the design because people are concerned about maintaining the integrity of the things that they have designed. Then you move on to the package and assembly part. Again, another set of tools that are involved in the packaging of these devices, in the assembly of the devices, and the testing itself. So what you can see is a series of supply chains or supply networks. It then goes from that to actually putting it onto a board, putting it into the packages that you saw earlier, and then logistics. So you're looking at a very, very complex supply chain involved with semiconductor manufacture from the time it's conceived in someone's head to the time it actually gets into a product that you're able to use.
Thank you, Carl. And thank you to all our panelists for those great introductions to your areas of interest and expertise. So this brings us to our discussion topics for the panelists, and then we'll open up the floor for questions. So let's start with the first topic, and that's providing resiliency to buffer existing supply networks. So one topic is feedstock versatility, or the versatility of manufacturing inputs. So is this one approach to diversifying, or how can we increase our versatility in feedstock supplies? Sunil, do you have some thoughts on this one?
Yeah, so as an industry, we have relied on petroleum feedstocks as one source of feedstock, right? And that's fine. Biomanufacturing offers another source of supply for those same chemicals. But it's not just that it's just biomanufacturing. You can have sugar from very different sources, right? You have sugar from corn, sweet sorghum, sugar beets, sugar cane, cellulosic feedstock. So that's one way to diversify what your starting material is going to be. That's the input for your own manufacturing. So when you are not reliant on a single source, it does result in more reliability in that supply chain itself. And biomanufacturing offers you that advantage.
Thanks for those insights, Sunil. Let's move on to topic number 2, so providing security to supply networks in the face of threats. So with this topic, I'd like to think about managing supply network risk from end to end, and what are some options for protecting supply networks from threats, ranging from feedstocks, equipment, workforce shortages, cyber threats, and improving security seems critical for all of these. So Carl, how do we define security in this regard? And what are some of the approaches being explored? So who's leading the charge for innovation in this space?
Wow, that's a big area, and I'll try to approach a certain part of it. So when you think about security, it's often thought about in terms of addressing an active threat or an individual. But the reality is what you're talking about, it includes things that my colleagues talked about, humidity, control, water intrusion, heat excursions. Each has a separate aspect and specific actions required. As I mentioned earlier, intellectual property is a consideration. Who handles the technical documentation? How is that protected from intentional or unintentional theft? Are those materials involved in that going to be enough for an IP release? So thinking about different aspects, and what you're really talking about with security is reducing the risk of an unauthorized exposure to or release of that information to other individuals.
Mm-hmm. And then are there differences in the definition of that security across industries? So how can different supply chains actually be secured?
So I'll go back to one of my favorite subjects, and for all the other double E's in the house, please raise your hand and say, that's great, we love it, and computer scientists too. But in the semiconductor industry, one of the things that has been discussed, in particular with manufacturing, actually design, manufacturing, package assembly, and testing, is improving what's called zero trust, which in effect is how do you monitor and ensure that all of your resources are adequately protected, who gets authorized to view those resources, utilize those resources, so that it's basically a 5W1H, who, what, when, where, how, and why. Who gets access, when they get access to it, why they get access to it, and how you ensure that those policies are active and actively changing depending upon what step of the process you're in.
Mm-hmm. And then Sunil or Wally, other examples of this from biomanufacturing?
So I think Sunil can answer this better than I can, but one of the interesting things about biotechnology that differentiates it from the semiconductor industry is that part of the process and part of the intellectual property for producing these materials and molecules is actually the DNA, the software that runs the manufacturers that basically are the cell. The cell is a manufacturing entity. Sunil?
Yeah, so from the industrial standpoint, I'm not going to pretend to talk about security in a room filled with US government officials. So from the industrial standpoint, we think of inventory as another form of security, right? So for us, our industrial and government partners, for them, security in a way is, can I have guaranteed supply of this chemical that I'm now reliant on? Can I have guaranteed inventories of these chemicals that I'm reliant on? So in that way, we do need to make sure that whatever we develop, we have to ensure that supply is not constrained. So in a way, for us in industry at least, guaranteed supply is a form of security.
Mm-hmm. And then, so switching gears a little bit, Carl, can you help us understand the difference between risk and resilience? Is there a common definition for both, or do different sectors think about them differently depending on their operations?
Thanks, Dan. So the answer, yes, there are different aspects of the definitions for different industries, but what's important is that there's enough overlap between those two so that you can begin to move forward and apply things across the board. So one of the ways that I like to look at risk is a function of threat, vulnerability, and consequence, where a threat is a specific and credible information that a component, a system, a service might be targeted by either adversaries or unauthorized personnel. A vulnerability, on the other hand, is a weakness that's either inherent to that component, system, or service, or has been introduced by an outside agent. So a supply chain risk exists when the capability and intent of an adversary or unauthorized persons, or in the case that we've seen recently, unforeseen circumstances, align with the opportunity to exploit a vulnerability. On the other hand, resilience is the capacity to absorb stress, recover critical functionality, and thrive in these altered circumstances. So when you have resilience in supply chain, three things happen immediately. First of all, the immediate impact of that shock can be reduced. The speed of recovery can be faster, and the extent of recovery can be higher because of things that you've put in place, where you're talking about whether it's monitoring, modeling, all things that are critical to understanding what's happened. Ann?
Mm-hmm. Great. And so let's move on to our next topic. Let's talk about the future. So topic 3 is preparing for supply network instability. And our panelists can offer perspectives on modeling and other methods of predicting supply network disruptions. And this is to promote awareness and possible mitigation strategies. Wally, first question is to you. So how can we improve the prediction of supply chain disruptions and instability?
So our approach has been to develop these dashboards that I talked about in my presentation. So we want to be able to provide a detailed, dynamic model of a supply chain or a supply and demand network. This includes supply chains for products, services, as well as technology supply chains. So being able to model them such that we can then do what ifs and start to look at predictive modeling, so we know maybe what's going to happen before a potential disruption happens.
Okay. So sometimes it's easier to ground our discussions in a real world example. So let's talk about examples of raw material or supply chain disruption with wide-ranging global and geopolitical effects and the approaches to mitigation. Wally, do you have an example pertaining to urea that you could share?
Yes, exactly. It actually kind of echoes back to some of the previous conversations where we looked at Ukraine and what are some of the effects on different supply chains. So the Office of Commercial and Economic Analysis sponsored a case study specifically on urea. The bottom line up front is that global actors have restricted urea exports, conserving their supply for internal use in anticipation of Russia's invasion of Ukraine. Urea is used globally for diesel exhaust fluid and for fertilizer. Restrictions on exports and imports of urea has an impact on global food production, as you saw before with wheat, as well as the cost of transportation and even the use of our recreational vehicles. So historical failures with respect to food supply security has contributed to exacerbate these restriction policies. While the global pandemic adds to the level and the rate of change of the urea availability in the global commodity complex, it wasn't the main driver in the increase of the price of urea. Specifically, South Korea and Australia have been particularly affected. Long term, the urea prices will normalize at a higher level once the global storage capacities have been achieved, and they'll settle slightly when and if the Ukraine situation is successfully resolved.
Mm-hmm. And Sunil, what about specific examples of raw material or supply chain disruptions from biomanufacturing or biotechnology?
Yeah, so actually, a pretty recent example. So, excuse me. In the early days of the pandemic, when vaccine development was happening, there was one component called squalene, which is quite widely used in vaccines. It's an adjuvant used in vaccines. The only source of squalene, excuse me, the only source of squalene is actually from the liver of deep sea sharks. And a quick back-of-the-envelope calculation indicated that to meet the global vaccine demand against COVID, you would need to kill about 500,000 sharks just to get enough squalene. Now, how long does it take to hunt 500,000 sharks? Actually, probably a few months. I actually don't know. Here's the rub. I mean, you can make squalene in fermentation. So if you had a source of squalene, if you had a strain and a process for squalene ready to go, you're talking about a 1 month, reliable squalene on demand, right? So now we ended up developing the strain and process. It took us 6 months. We are actually in clinical trials right now. So it wasn't ready in time. But the question is, how can you anticipate that in the future and start hardening your supply chain by investing in technology like that?
Mm-hmm. Thanks, Sunil. Carl, example from electronics.
Certainly. One that I think has impacted or potentially impacted people here is the impact with regard to the automotive market. And in fact, I had a conversation last week with some consultants to the big three, and there are literally thousands of automobiles sitting in lots because of the shortage of chips. One example given in particular, that the chip that's used to deal with heating your car seat. So that, again, has been hitting and continues to hit while that shortage exists. So basically, the key and what we've been talking about is how do you ensure that there's an adequate supply of the mix of integrated circuit chips that are needed for a wide range of applications. And so it might in some cases mean moving away from quote unquote just-in-time manufacturing to ensuring that you have an adequate supply of the chips needed to absorb shocks and then deal with resilience.
Okay, so we've gone through our topics. I'd like to open the floor to questions from the audience on the app. And then here's a little instruction on how that works. But to get us started, I'll start with a question. So what supply chains are adaptable to provide more resiliency? So Wally, do you have some examples of adaptable supply chains that can become more resilient?
Well, so I think it all kind of depends. Any supply chain can be made more resilient. It kind of depends on the return on investment. I mean, how much are you willing to pay for that resiliency? Do you need to invest in the biomanufacturing of squalene, so that we are more responsive for a particular type of molecule? So it might cost more, but it could give you an advantage rather than waiting for enough sharks to be harvested.
Great, thank you very much. So we have another question from the audience. So what are the challenges in hardening supply chains for traditional manufacturing versus agile modular manufacturing like biomanufacturing? Sunil or Wally, this question is to you.
So I think it kind of comes back to the comment that I made before that sometimes with biomanufacturing, it adds to the complexity in that you're using DNA, which basically is the code, the intellectual property. So if samples were stolen in any part of the process that reveals that DNA, it reveals the intellectual property that companies like Amyris have done a lot of work in trying to develop. So I think there's added complexity from that aspect. You don't have, like when you're making a semiconductor, you don't have the recipe for making the semiconductor etched into the package.
Mm-hmm. Right. Sunil, did you have some thoughts on there on for biomanufacturing particularly?
Yeah, I mean, the part about it's easy to, if you could access the strain or the microbe at a facility, and you can protect your IP, but yeah, someone can access it, sequence it. So that's a threat that we have to address. But in terms of on-demand manufacturing, or let's put it this way, more flexible manufacturing systems, you can take a strain, a microbe, and a process and go to a CMO in the US, right? You don't necessarily have to stick with one location. So if we had a network of contract manufacturing groups across the United States, you could access different facilities to actually ramp up your supply or ramp it down as per the market requirements, right? But yeah.
So security in that type of supply chain is the availability
Yes.
of those capabilities, those resources.
Yeah, exactly.
Yeah, manufacturing infrastructure. So, and we have another question. What tools are available to secure supply chains? And then what about securing the tools themselves? Carl, this seems like a good question for you.
Certainly. I will, again, focus on semiconductor manufacturing. There, in fact, are existing standards that are being developed to specifically address the cybersecurity of the tools that are utilized. Because if you think about the tools themselves at certain steps in the process, gather the information and can in themselves be revealers of the IP, of the particulars of that process that are being used. And so in looking at how you secure that, again, I'll go back to some of the aspects of zero trust, which really is how do you address and protect the services, if you will, the information, the critical information that needs to be protected during design, during fabrication, during package assembly and testing. It all goes back to what are the combination of physical security as well as the cybersecurity techniques that are critical to ensuring that unauthorized access is minimized and you have ways of addressing when those perturbations do occur.
Mm-hmm. And then Wally or Sunil, any ideas on tools to secure a supply chain or security for the tools themselves?
I think from my perspective, a lot of the companies out there are developing the tools themselves, and so they have to rely on their own security to not only protect the intellectual property. A lot of the intellectual property is in their databases and in the skills and abilities of their computer scientists, the people that do the omics, that evaluate these different things. So we do rely a lot on cyber cyber physical security to protect those things. So we're accessing other tools that have been implemented in other cyber realms to protect that information. It's very data intensive.
So switching to examples of tools, so thinking about supply network disruptions. So to mitigate supply network disruptions, are there tools that you know of that are available to do that?
I think those are the types of things we're actually trying to develop right now.
So the network-wide disruptions is the tricky part.
Part of it comes back again to the modeling of those supply chains and figuring out, predicting when those disruptions are going to happen before they get there, understanding what your supply chain looks like and what the characteristics of it are. So in your case, it was like understanding what the CMO's capability and availability is to be able to secure. So sometimes it's networking. I know some of it's informal, but
Yeah, the other part of that is it's not necessarily protecting the tool, but do we have enough capacity in itself, right? So one way to increase the security is to just make sure we have the access to it. So let's be frank, right now for fermentation capacity, there's not enough fermentation capacity in the United States. So you can invest in it, and we can increase our own security domestically so that we have access to some of these newer manufacturing paradigms, right? So, and the other, I talked about how someone can steal a microbe and figure out how to use it. It's actually not that simple because, fermentations this is not like you're, making beer in the garage, which, is fun. But these fermentations have to be precisely controlled. So just because you have the microbe doesn't necessarily mean that, wow, I can now start making squalene in my garage. It doesn't work that way, right? So there is some inherent security itself in how difficult it is to scale these processes up. There's a reason why they call it precision fermentation, because that's what it is.
If I could add to that, there are companies that you can look up that deal with supply chain security, in particular companies that develop models of how you actually look down to the lowest tier of your supplier within a particular network and have an understanding real time of what their inventory levels are and how that potentially impacts what would happen moving forward. One individual from a company mentioned to me that it stood out for me, and I thought I'd share here, and that is that companies don't compete with each other. Their supply networks are what's in competition. The ability to deliver goods, services, products on time in the volumes needed for a specific customer is directly related to the security of that supply chain.
Okay.
And then it's very important that for that type of tool that has insight into the inventories, capacities, the availabilities, but that data has to be available. Those companies have to participate by subscription or by contract and provide that information such that you have visibility into those depths of the supply chain. When you start your car, and let's say you're still using one that uses gasoline, you don't think about the health of the truck driver who took that gasoline to the pump that you produced it. You don't know. You don't have visibility into that network. But at some point, we're going to need that in order to develop tools that give us the resiliency that we need.
Right. Let's take another question from the audience. How is this biomanufacturing effort different or complementary to the different Manufacturing USA institutes that are also focusing in this area? And the example they give is BioFab USA. BioMade would be another one. So
Yes.
does anybody want to take that one, Sunil?
Well,
Yeah, BioMade is, when I saw the question, BioMade is exactly what I thought about. So, biology, we like to say that our understanding of biology has increased exponentially. That's true, but biology is still inherently highly unpredictable. And so I would say we're just starting to scratch the surface in that sector. So a lot of the other manufacturing institutes, are focusing on different problems to solve. I think BioMade is trying to essentially fill the gap on the biological side. So I think in a way it's different because the problems you're trying to solve are going to be different, but it's complementary from how it was set up and what it's trying to solve for. So Amyris, again, we are part of the BioMade effort. It's a fantastic initiative. And I think that, again, we're starting to see some benefit of a manufacturing institute like BioMade.
Yeah, so BioMade focuses mainly on the scale-up and downstream processing to survive that. I mean, we can design a lot of different things, and we can make them in the laboratory, but sometimes we run into trouble doing it in your garage versus making 1,000 million or whatever gallons that the breweries make on a daily basis. Scale-up is not a trivial thing, so that's where the investment, I think, in BioMade really is. Biofabrication, the biofab facility is more about how do you basically print tissue, how do you print organs that we can use to treat our warfighters in the event of injuries.
Yeah, I'll just add to that. It's what I think what Wally is referring to is in industry we call it the valley of death. And that valley of death is actually when we're transitioning from the laboratory or even the pilot scale to actual commercial scale manufacturing. Because when something goes wrong at that scale, you are in trouble. That's a huge risk that you don't want to take.
Right.
All right, we have another question. How do you encourage resilience? So talking about profitability seems that would only drive towards efficiency. So for example, if other biostock is more expensive, it will not most likely be pursued. Do you have an idea there?
So that's one of the things that the Department of Defense does, and we do in the Air Force Research Laboratory. Our investments, so the Air Force, the Department of the Air Force doesn't make anything. The industry makes it, and it's our job to make key investments where we take the risk out of the development of a particular material or product. It's important that, though, we design resilience into that, going back to the definitions that Carl made, so that when we have disruptions, that they don't have as much impact, but that costs money. Okay, so if you go into a project and we say, okay, we're going to use sugar, that's the most efficient way of doing it, but the government says, well, that's great, but what if I can't get sugar in this forward operating base where I actually want to use this process? How do I leverage existing biomass that I can find on site? And so it's that additional capability that we're asking for that provides the resilience. So it's actually designed into the process for producing whatever the material that we're looking for. Mm-hmm. Okay. At the point of use, hopefully, at some point.
All right, we have another question. So is there a plan or a program to keep the manufacturing of these new technologies in the U.S. as they mature?
So BioMade is one way that we have a public-private partnership with industry. There's also, in each of the services, there's a manufacturing technology program. There's actually a Department of Defense manufacturing program. And they have an annual conference every year. This time it's in Tampa. It's called the Defense Manufacturing Conference. And it's the JDMDP, the Joint Defense Manufacturing Technology Program. And their job is to make the investments that will help mature these technologies. Once we've got the people that develop the intellectual property, develop that key thing, Mantech's investment is how do I make it at the right cost, affordable, and how do I make it at the right volume? And in some cases, when I'm making that thing, it's at the right yield, so that it gives us the titer that we need that gives us the high purity of product. So yes, there's quite a bit of investment in what we call manufacturing technology or Mantech.
Yeah, it's a very good question. And this is getting the attention of everyone from the private sector, investors, the government, academia. So the Schmidt Futures, which is a fund that was started by Eric Schmidt, ex-Google CEO, they had put together a task force, and the task force brought together people from industry, the government, and academia to answer this exact question, right? And so the question is, what will it take to make sure the U.S., right now, the U.S. does have a lead in the sector, but let's not get complacent about it, right? And so how do we maintain that lead? How do we make sure that all these new technologies get manufactured stay in the US itself. And so there are investments to be made. And these are investments that the private sector can make. There are investments that the US government can make in the infrastructure itself so that we can continue to manufacture in the US. So it's a Schmid Task Force report. I think if you go to their website, you can find it there.
Great. All right, I think we have time for another question. So let's look at the potential critical components that are needed to become more resilient for both fields. And I'm assuming when fields is mentioned, they mean semiconductors and biomanufacturing.
Well, that's a very good question. That's a question that I'm asking right now. I'm asking the Department of Commerce because they have some tools that allow us to look into different supply chains and pull out what are the critical elements that particular supply chain is interested in. From my perspective, I don't have that answer right now, but we're trying to develop programs that will give us that. Potentially, one of those programs could be a DARPA program by Dr. Mark Flood. It's called the R. Sudden program, which is specifically, it's an acronym which is Resilient Supply and Demand Networks. And so they're looking at developing these type of tools that will identify the critical components and do that predictive analysis so we can make the investments in those fields before it bites us.
Right.
Yeah, I mean, I think all of them, yes. But I mean, it'll vary from chemical to chemical, right? Because certain chemicals will have certain manufacturing processes that require something very unique to them. So, it depends on the chemical. But let's say you even solve for the critical components themselves, right? There could be other bottlenecks, right? You might produce it by fermentation in one location. You might need to purify it somewhere else, right? Because if I'm going to supply a chemical to the Air Force, I have to purify it. And so that then results in a shipping logistics issue, right? How am I going to get it from point A to point B? That's going to add cost to my supply, to my material. So in addition to just the critical components, I also had to think of logistics. And that can also be a bottleneck for something like biomanufacturing, where we're still, we have the infrastructure in the US, but we're still figuring it out.
Right.
I'll answer in a slightly different way, and that is when you look at critical components within semiconductors, you're really talking about a very, very complex, interconnected set of networks and machinery and software. So I would say that what needs to become more resilient are ideas for manufacturing in new and innovative ways so that we can better predict, better get through, and improve on the other side. Part of the reason we're here is to talk to you all to begin to receive some of those ideas. And it also includes the people part, because we're looking for folks who have, as Steve Barton would say, the wild and crazy ideas that we're willing to take on with the risk that a place like DARPA is willing to handle. So that's, again, instead of going into detail about, well, we need this for this tool, this for that tool, no, it really is a collective push forward with innovation, innovative ideas, specifically regarding how we manufacture and how we address the existing ecosystems, and even thinking about potentially new ecosystems within how we do the manufacturing.
Well, we've reached the end of our time. Thank you so much for a fantastic discussion, Carl, Sunil, and Wally. Let's join me in thanking our panelists.